It looks like HR want us to get rid of all the minions that we've got working in the null zero labs data centers. Problem is, we've got hard-coded usernames and passwords across all of our Cisco kit and other networking equipment. That's going to take time to remove all those usernames and passwords and make sure that they can't access our equipment without us knowing. Here comes Radius to the rescue. Let's get in the lab. Here we are in the lab. As you can see, we've got quite a few devices. Not that many, but in the real world, this could be hundreds, maybe even thousands, depending on how large your network is, across multiple locations, multiple regions, etc. So here we can see we've got all of our routers interconnected. They are all reachable between each other. We've started to put in place our 2 Radius servers for acting as our central point of authentication for our devices. At the moment, Bob's username and password is on every single one of these routers. Our goal by the end of this video is to make sure that whenever we log into one of these devices, it is authenticated against a central source. And then that gives us the ability to easily control if we want to delete that person, change that person's password. We can do it all within one location so that we don't have to then go from one router to the next router to the next router to the next, just to lock somebody out or to change a password in the future. Now, the way that we will do this is that we will create a backup username and password on the device, and that gets used as like a last resort. Now, the idea of that username and password is if the Radius authentication goes down in any way, or we take the device off network and we want to log into it, we know that we have a stored set of credentials that nobody should be using on a daily basis that we can use to log into this device. We sort of set those accounts, that username and password up, we lock those away in the cupboard, we don't use them. On a day-to-day basis, whenever a user logs in, they'll authenticate to the Radius server. Now, let's log into router 1, and we can see that we're given the standard login prompt. We managed to get Bob's username and password. His username is Bob, and he's not very secure. His password was Cisco. As you can see, that's dropped us in to a non-privileged mode. Here we can do things like show IP in brief. We can do basic diagnostic commands at this level. Now, if we want to go into the enable mode, again, he has got a password set as Cisco. Again, not very secure, but he has set a password. From here, we can do things like show run, and we can see the configuration. We can also reboot the router. So if we look here, we can see he's set a hard-coded enable secret. And he's hard-coded his username and password. Now, this is the same on all of these devices. And that means I've now got to connect to every single device and change this password so that he can't log in. Now, like we said, that's time consuming. And in an ideal world, I'd like to be able to have a centralized source for usernames and passwords. So thankfully, I've gone ahead and I've set up a Radius server here on this data center's switch that is reachable from all of the other network nodes. And I'm going to configure this router now to authenticate to this Radius server so that I can log in with my credentials and I can remove Bob's account. Let's start with that now. So the first thing we're going to do is we're going to create that local account that I said. So we're going to create a username of local-admin. Privilege level will be 15, and we'll set a secret. Okay. Obviously, don't choose Cisco, choose something more secure. So that's our backup username and password to get in. At the moment, I could log in with that because it's a local account. So I could go local-admin and we set it to Cisco with capital C, and you can see I'm in. The enable password is a shared password resource. It's there by default on the device. So now, if we change the enable password as well to the new one, so we go enable secret, and I'm going to set it again, but I'm going to set it with a capital C. We're going to store those away. So those are now our backup credentials. We've got a backup enable password and we have a local user account. Now we can go no username Bob. Now we do show run. We can see Bob's account has been removed from this device. Great. He can no longer log in. But again, now we've got this one single account on here, we're back in the same boat again. Somebody gets this password, I then have to change them all again. So the easiest way is we're going to create an account on here, on the Radius server. We're going to set the Cisco router device to point to there for its authentication, and we're going to log in that way. On this one at the moment, I've already created my account, so we'll go to that in a minute. But what I'll do is we'll set this router up now so that it authenticates to that server. So first of all, we're going to need a Radius server. So we need, first of all, we need to make sure we've got AAA new model enabled. And then we're going to go Radius and yep, server. And we'll call this Radius 1. Then we're going to give it an address, IPv4. And its address is 192.168.20.10. The authentication port is going to be 1812. This is a standard port. And the accounting port, which is something we'll get into later, is going to be 1813. We're now going to set a secret key. So the key will be Radius secret. Now if we show a run and we have a look at the Radius section now, we can see we've got a single Radius server added. Cool. Let's change the authentication system. We can see here that we're set to authenticate to local. Let's change that so that we can authenticate to the Radius server. So we're going to change that to AAA authentication. And we're going to set authentication login, because obviously we want to log into the device. That'll be the default authentication list for now. We will change this later when we create a group. And it will be Radius. Radius and then local. What that does is that now tells the device you should check the Radius server when a user logs in. The local on the end means that if it can't reach the Radius, it's going to fall down to that authentication method next. So next we need a couple more commands. Authorization. Exec. So this is to get to the exec prompt. Again, it's going to be default. And the group will be Radius and then login, local. Okay. And to make sure it does, maintains authorization console. There we go. So these three commands will be enough for us now to authenticate to the Radius server. What we need to do now is we need to set the source that this is going to be using to authenticate to the Radius, like what IP address we're going to be sending. And we're going to do it from the loop back. So the IP Radius source will be loopback 0. This just tells the router to use the loopback IP address of 1.1.1.1 when it's talking to the Radius server. Now, if we jump onto the Radius box, get into privilege mode, ECT/FreeRADIUS, everything lives in here. Okay, so first of all, we need to add a client, and the client is the router, the NAS device. So we're going to add that. So we're going to edit the clients folder, and we're going to add a new client. As you can see, we've already got 2 in here because I've been busy locking Bob out of our 2 data center switches. So we're going to go client, and we're going to call this R1 for the router 1. We're going to open and close our curly braces. We're going to set the IP address, and its loopback is 1.1.1.1. I'm going to set a secret that we've set on the device. That's what it's using to encrypt the traffic between the router and the Radius server. And we set that to Radius secret. So that will add the client there, and then we need to restart the service. So that it picks up the configuration that we've added. So now, if we jump back onto router 1, now you can notice I haven't saved the config at the moment because the changes I've made, especially if you're doing this remotely, you could lock yourself out. So ideally, we've made the changes, we're going to test it. So as a last resort, if we lock ourselves out, we can get someone to quickly reboot the router. It will boot back up with the configuration that we made before the changes. We'll be able to get back in. So now my username on the Radius boat is Matt, and then I'm going to put my password in. And now you can see I'm logged in. You can see I'm dropped straight into the privilege level of the enable prompt because I have a privilege level of 15. So if I show my privilege, you can see I'm set as 15 because on the Radius server, when I added my username, I set my account to be a level 15 admin. Now I can see that I can log in. It's working as expected. I can reach the enable prompt, and I can reach configuration mode. So now I can authenticate all day long to this server now, directly to the Radius box without having to rely on a local username and password. As you can see, my username is not stored locally on this router. Okay. Now, as you can see, when I log in, when I log out, not only do we have the benefit of not having our username and password stored locally, we can also now individually identify users when they log in and log out. Whereas before, we just had this single local user account or Bob doing it. Now we can see individual engineers connecting to the device. So as you can see, I'm a privileged admin when I log in. What if, say, you had a junior and you only wanted them to have a login so that they could log into the device and maybe show if an interface is up or down, or see if there's a VLAN, or see if they could ping to a address or show the routing table. So we can do that. So if we jump back onto our Radius server, what we'll do now is we will jump into a different file, and this one is called the users file. So you can see here's my account and what it looks like on the Radius server. We give it a username and a password. We have to set that it's a NAS prompt user. The NAS is the Cisco router. It's a Radius term. And then we send back that this user is a privilege level 15. So there's 16 levels from 0 to 15. 0, 1 and 15 are set. So 0, if you send back a privileged user with 0, they can log in, they'll get to that first prompt, they can get some very basic show commands and not very much else. A level 1 will get what level 0 had, and will have the ability to do some extra commands and the ability to enter into, say, enable mode if they are given the local enable password. We can also make the Radius server handle the enable password by adding it in here, and then if anybody logs in and uses the enable password, it can be authenticated here locally. So we'll do that as well. And then finally level 15, which is your top maximum privilege level, shows that you are a full admin and have full control over the device. Levels 2 to 14, we can specify which commands we'd like to put under each of those. So we could say group the reload command under 2. And then basically anybody who has a level 2 privilege could log into the device and they could do a reload or reboot the device. So now let's add our junior guy, and we will call him Ethan. Okay. So now we have our 2 users on the Radius server. If I log out of the router, I can now log in as Ethan. The joys, eh? There we go. Right, so we change the user, we restart. Ethan. Fortnite, he's in. There we go. Now if we do a show, we can see he can do basic commands like show IP int. So we can see that he can show IP root. So you can do some basic show commands. You can show IP int brief. Yep. So you can see with his user credentials, he can enter enable mode. So if at some point we needed him, absolutely he must do something for us, we could give him the enable mode password and he can then get the level 15 privilege that he needs to be able to make a change for us remotely. Then once he logs out again, we could also then log in and change that password, or we could make that enable password authenticate to the Radius. So let's log back in as me. Now, if we look, so far we've covered 2 of the A's, because AAA stands for Authentication, Authorization, and Accounting. Now let's look at the 3rd one, because not only does the Radius server check and allow the authentication to happen and authorize the privilege level, we can also do accounting. So we can log that user has connected to that device when they started a connection and when they disconnected the connection. And that will help us, like if we wanted to know at what time, if there was a security incident on that router R1, we'd be able to check and see at what time, which username was used to log into that router. So let's do that bit now. So we go AAA again, and now we do accounting. And we're going to account for when they start an exec session. So it's going to be default because we don't have any groups. And when they start and stop an exec session, and we want to send that to the Radius server. What if they were to connect out from here, say SSH to another router? So we'd want to account for that as well. So we can do that by doing connection, and again, default, start, stop, and the group is Radius. So now if I log out and I say log in as Ethan, okay, you can see I've logged in. Now if I go over to the Radius server, there will be a folder in the var/logs directory. We should see that there is a folder called FreeRADIUS. So if we log into there, and then we can see that there's a log file, an actual Radius log file that we can see. And that's just the basic log file of the config when it starts up, etc. And then there's also another directory called rad accounting. Now, if we see in here, we can see there's multiple, there's basically file names for each device that is accounting to the server. So the one that we're looking at is this one, router 1, which is 1.1.1.1. So if I have a look at that file, or if I change into it, sorry, it's a folder, because it's done by date. So now if I nano the detail file, we can see there that Ethan logged in. So now if he logs out and then I refresh this file, we can see that he disconnected, user exit. So we can see here the time the user started a connection and the time the user ended their connection. So the same again, if I log in with my details, and then I say I try and SSH to router 6, let's say, which was we haven't touched that one yet, so the local account will still be Bob. Okay, and now we're on router 6. So we've jumped from router 1 to router 6. If I exit that, now if I look at the log here, we can see that I made a connection in to the device. Here we go. And we can see that I started my session. You can then see, because of that accounting connection command that we did, that I then made a connection to one of the other routers and logged in over there, and the time I disconnected. And now finally, if I exit router 1 and I double check the file again, we'll see that my session ended on router 1 and on router 6. So just by doing that, we now have the ability to authenticate a user, name and password, to a central point. We have the ability to authorize what they're allowed to do, i.e., are they a privileged engineer? Can they access the enable mode? Can they access the configuration mode of the router? Or are they a basic user and they can only do show commands for simple diagnostics purposes? And then finally, we've done the accounting part where we've then said, hey, whenever a user logs into this router, I would like to know about it. I would like to know when they connected, when they disconnected. I'd also like to know if they connected to a router, if they then hopped to another device. And that's AAA, AAA. Authentication, authorization, and accounting. What happens if this radius box goes off? Well, let's see what happens. So let's stop the radius server. So the radius server has gone down, and now I try and log in. We can see that I won't be able to connect. The connection will time out, and I will get an authentication error because my credentials are not stored on the device. Once the device realizes it cannot reach the radius server and it times out, it will fall back to using the local credentials that we stored on there earlier. So now if I try and log in with the local -admin and the local admin password, it will be a little bit slower because it's double checking whether or not it can reach the radius server. Once it realizes it can't, it will use this username and password to let me log in because it will authenticate this to the local database. And this account only exists on the local database. It doesn't exist on the radius server. But if we start it back up, once the server fully boots, I will be able to log back in. But hey, you could have two of them online. So we could put our credentials onto the second box or have a shared database resource in the background that both of these radius servers are talking to. And we could add a second radius server on the router and add a radius group. And then that way it can try both radius servers. If one's not alive, it will move over to the second one, etc. Vice versa. And then that way you can guarantee most of the time you'll be able to authenticate. You could do it another way in this day and age now where you could have the radius server operating as a VM, and then obviously you could live migrate the VM across your host infrastructure, so you can pretty much guarantee that it will always be online. But hey, if we've got two, let's use two. I know we're then having to store the password in both places, but again, this is a lab environment. In a real world production environment, you'd probably want some kind of shared backend for storing the username and passwords. Maybe integrate your radius server with LDAP and install all of your users into the LDAP system, and then your radius servers pass the authentication off to the radius to the LDAP server to authenticate the actual user account, and then the radius server will hand back the privilege and do the accounting part. So let's log into router 1 again, and then let's add the secondary radius server for the redundancy. So we're going to add the secondary radius server, radius 2. We're going to enter its address, IPv4. That's 192.168.10.10. Again, the authentication port is 1812. The counting port is 1813. The key will be radius secret. So we'll jump all the way back down there, and we'll see now that we have our two radius servers. So now let's create a group. We're going to go AAA group. radius, and we'll give it a name, rad group. And we'll put the server name, and we did radius 1 and radius 2. Now if we look, we can see we've got our radius group. We've got our 2 radius servers, and we're calling them by the name. Now we're going to update our authentication, authorization, and accounting section to use the group rather than just radius. So we're going to make some changes here. So it's going to be config T. Let's just jump to there just so that we can see it as we're changing it. Now, if we look, we can see we've got our authentication, our authorization, and our accounting now set to use our radius group that we created. So the next step is to jump onto the secondary radius and add it as a client like we did on the first one. We'll edit the clients folder. Again, we're going to add a new client, R1. Open and close our braces. The IP address is 1.1.1.1. The secret was radius secret. And before I restart, we will just double check that I do have in the users folder, I do have my account set up. We'll also add Ethan. There we go. Right, so we now have the same usernames and passwords on the 2 radius servers. Like I said, in an ideal world, we'd have a centralized backend and we would be using that backend to manage those user accounts. So now if I log on to router 1 again, already logged on, aren't I? There we go. So if I exit there and I log in with my details, we can see I can log in. Okay, so now that we've got our radius group configured and we have our AAA configuration completed, now if we stop the first radius and we attempt to log in again, we will see that it will divert over to the secondary radius server for authentication. Obviously, it may take a little while whilst it goes through its dead timer phase, but like I said, some of those elements can be tweaked within the radius server section. You can tweak the dead time, the timeout, etc., and the retries. As you can see, we are now authenticated, and this radius server is off. So there we go. There we go. It's now showing it's not responding. So now this router can authenticate to radius 1 and radius 2 in the event of a failover. So now that we've successfully configured one device, let's move on and configure the other devices so that our complete network is using radius 1 and radius 2 for authentication. And so we are back in. So if we do a show run, verify, again, we've got our local enable password. We've got our backup local admin account. And we have our radius servers. So we will save that. We're at 5, we're in the home straight. Bob is nearly fully locked out and gone. And we will double check route of 6. So Matt is my Radius account. And there we go, we are in. So if we save that, there we go. All of our routers are now authenticating to our 2 Radius servers. Okay, so now all of our devices, as I've said, are now all authenticating to Radius 1 and Radius 2. In the event that Radius 1 goes off, the engineer's login details are authenticated to Radius 2. We have our 2 user accounts on there. High privileged engineer at level 15. He can log straight in and has full access over the router. We have a privilege level 1 user, and they can log in and do basic show and diagnostic commands. We were storing the user's credentials on the Radius server in clear text. If we didn't want to store it in plain text, we would change this to a SHA-2 password, and in this field here, instead of it being the plain text password, we would enter in the hash and store that. If we look at how you would generate such a hash, you can type something similar to this on your Linux command line, where if I take the password of your password, feed it into the SHA-256, and then print it out as the SHA-256 hash, I would copy and paste that into the user, the SHA-2 password equals, and I would replace that clear text password with the hashed password. And finally, what about if we wanted to authenticate the actual enable password against the Radius servers as well, instead of using the local backup enable password? We can do that, but as per the FreeRADIUS documentation, we have to use this special username here, $enable $15. Now, if I jump over to our Radius server, I've added that username and I've given it a different password, what we stored on router 1. Now, another thing to note on router 1 as well, for it to work, we need to add an additional line. So I will log in with my credentials first. As mine drops me straight in, we need to add another authentication line where we say we want to authenticate the enable password against the Radius server. So again, now that we've added that line, but if a low level user drops in, like the account we created for Ethan, and his password was, what was his password again? Fortnite. We can see he's logged in as before, and he has the very basic privileges that he can use. But if he then goes to enable, and we use the password that we stored on the Radius server, which was Radius Cisco, we can see he can now log in and has the access level required to be able to do tasks and services that we need to change for them. We can then, again, if we need to, and say, oh, we don't want that person knowing what that Radius password is, we can jump into here and I will now change it to something different. So we will change it to just Radius pass. And I restart the service. Now when Ethan logs back in with his low level account and he goes to enable and he goes, oh, it was a Radius Cisco, wasn't it? And he goes to do it, he gets an error. And if he tries to use the local password, it no longer works. And finally, if we use the new one that we set up, radius pass, we can see we have enable access. So there we go. We've fully secured our network today using Radius. We've fully done authorization, accounting, and authentication for all of our devices. We now can add and remove users into 2 locations. We can manage the enable password for each device in the same 2 locations. And finally, we've also learned how to store the passwords in the files as a SHA-256 hash rather than in clear text. So I hope that was useful. So thank you very much for watching.